In Module 3, we'll take a look at computer vision. So we'll look at some computer vision concepts, we'll talk about what computer vision is and some applications of computer vision, and then we'll look at computer vision specifically in Microsoft Azure, so the cognitive services that we can use to work with computer vision, and then specifically we'll look at image analysis with the computer vision service, we'll look at training models with the custom vision service, we'll look at analyzing faces with the face service, and then we'll look at reading text, again with the computer vision service, and finally analysing forms with the form recognizer service. Let's start with lesson 1 and look at some computer vision concepts. So first of all, what is computer vision? Well, computers can see the world through digital images, such as photographs or live camera feeds or recorded video files. Now each digital image is actually an array of numeric values that indicate the colour intensity of each pixel in the image. And you can use these values just like any other data as features to train a machine learning model or to apply transformations and calculations to analyse the image and find patterns within it. Now in the case of colour images, there are actually 3 layers of pixel images, one each for red, green and blue pixel intensities. So what are the applications of this? Well, most computer vision solutions are built using a combination of machine learning models and some advanced image analysis techniques. Common applications of computer vision include image classification. Now, an image classification model uses the numeric pixel values in the image to predict the class label for the image. So, for example, in a traffic monitoring solution, you might use an image classification model to classify images based on the type of vehicle that they contain, such as taxis or buses or cyclists and so on. Essentially, image classification models answer the question, what is this an image of? Now, another form of computer vision is object detection. And object detection models are trained to classify individual objects in the image and to indicate their location within the image as a bounding box. So for example, we could expand that traffic monitoring solution to detect the presence of multiple classes of vehicles in a single image. Object detection models are used to answer the question, what objects are in this image and where are they? Now moving beyond there, semantic segmentation models are an advanced kind of model that classify individual pixels in the image based on the object that they belong to. So for example, in our traffic monitoring solution, we might use semantic segmentation to overlay these different masks on the individual objects to indicate the pixels that belong to buses or cars or cyclists and use different colours for each. So semantic segmentation answers the question, which pixels belong to which object? Now, building on these types of models, so building on things like object detection and classification, you can perform image analysis and do things like generate captions or tags based on the contents of the image. So in this case, we've identified that this is a person with a dog on a street. We can also use face detection and recognition. Now, effectively, face detection is used to identify the location of a human face in an image, and then you can do further analysis to look at the facial features and determine things like gender, emotion, age, and so on. And you can also train models to identify specific individuals based on facial recognition. And then another use is optical character recognition. An OCR model identifies regions of the image that contain text and extracts that text. Let's take a look at some examples of computer vision in action. So this website has some interactive demos that we can use to look at computer vision. And we'll start off by analysing and describing some images. So I have some images here and I could just select one. And what I get from that are some tags. You can see there's water, it's outdoors, there's a skyscraper, the skyscraper's overlooking something, there's sky, there's a lake, reflection, and daytime. So I get those tags and I get some indication of confidence. So there's a machine learning model that is looking at this image, analysing it against some classes that it's been trained with, detecting the objects in the image and then using them to derive these tags and giving me the confidence, the probability that those tags are what it's detecting. I'm also getting a description of what's actually in that image. And it says it's a bridge over a body of water. Well, actually, there isn't a bridge. It's an island of buildings, but it's definitely over a bottle of water. It's checking to see does it contain any racy content or adult content. So it's doing a little bit of content moderation, and it reckons that this is false. This is a perfectly innocent image. And what I could do is try another image. So let's go and select a different one here, and maybe we'll just cut to the end here and select this one here. And again, I get the tags, and there are buildings, there's a road, there's a vehicle, there's yellow. So I'm getting all these different things that it's detected, these different attributes of the image. I get a description, a car parked on a city street with 96% confidence. So that looks actually reasonably accurate. And I get, again, my moderation down here. So as well as analyzing and describing images, I could read text in some imagery. So here's an example of an image with a sign in it. And if I look at the transcript, I get 42 street 42. Well, there's 42 and streets. And then over here on the right-hand side, there's a 42 there as well. So it's read all of that. And I could try a different image. Let's maybe take a look at this one. And again, a very small sign, no ped crossing, use crosswalk, and that's what comes up in the transcript. So it successfully read that text. Now that was printed text. I could even actually recognize handwriting. So if we take a look at this one, for example, free hugs being offered. And again, it reads the transcript down here. Now that's in block capitals, so you might think that's relatively straightforward. Let's try one that's slightly more realistic handwriting here with a mixture of upper and lowercase. And again, I get the transcript below. Steel cut oats with apricots, cranberries and spices, served with yogurt or milk, $4.50, which is what's up here. So it is able to take that visual input that contains text and use optical character recognition to extract that text. And then finally, there might be recognizing individual either people or specific landmarks or objects. So for example, if I look at this here, I can see that this is detected as being the Statue of Liberty with 96% confidence. So that's a recognized object that the computer vision solution has been able to read. I could try another image. We could have a look here, and this one is identified as being Satya Nadella with 100% confidence. So we have some facial recognition going on here, and we're recognizing that particular individual person. So let's move on and look specifically at some of the computer vision solutions in Microsoft Azure. Azure provides a set of cognitive services that encapsulate common AI workloads, and that includes computer vision tasks. Now you could build your own computer vision models using machine learning, and most commonly you would use a deep learning modeling technique called a convolutional neural network, or a CNN. Or you could use some image processing SDKs that are available for various languages. So for Python, for example, there's a whole bunch of libraries like OpenCV and scikit-image and PIL that you could use. But it's a very complex area. If you're not familiar with those things and you haven't spent a lot of time working with them, that can actually be quite a complicated task to take on. Using off-the-shelf services like we have with cognitive services can help you develop a solution more quickly and with less of that specialist expertise that would be required. Now, to use cognitive services, you need to provision a resource in your Azure subscription. And that can be a standalone service-specific resource. So for example, we could create a computer vision resource. Or there's a general cognitive services resource that you can use to encapsulate multiple services. So if you needed to use lots of services, you could use that. Using a standalone service-specific resource enables you to manage the costs and access to that one service independently of any others that you're using. But using a general cognitive services resource lets you combine all of your AI services into a single Azure resource and manage it centrally. So it's really up to you which approach you take, and it depends on how you want to manage that service. Whichever way you go, regardless of the type of resource you use, a client application will consume the services by connecting to something called a REST endpoint, which is just an HTTPS address that they'll submit their requests to, and they will use a resource-specific key for authentication. So when we create a resource, we get an endpoint and a key that we need to use from client applications that are going to consume that service. Now, the computer vision cognitive service provides a pre-trained computer vision model that you can use to analyze images. And this service is what powered that demonstration that we saw previously. Now, the model that's been provided with that, it's been pre-trained, and it can detect and locate over 10,000 classes of common object. It can generate an automatic caption for the image and a set of relevant tags that relate to its contents. Now, those tags, you might be wondering what you would want those for. They can be useful if you needed, for example, to index images and search them using relevant keywords. The model can detect and analyze human faces, including gender identification and age estimation. It can enable content moderation. It can identify images that contain adult, racy, or gory content. And it can detect and extract text in an image, which we'll explore in a bit more depth later on. The custom vision service, which is different from the computer vision service, enables you to train a custom model of your own for either image classification or object detection. Now, the service provides a web portal that you can use to upload your own images, and you can label them or label the objects in them, and then you can train and deploy your own model. Then you can consume that model from a client application using its model ID along with the endpoint and key for the resource that you provision, just like any other cognitive service. Now, earlier we saw that the computer vision service provides some basic face detection and analysis features. There is a specialist face service that offers some additional capabilities over and above that, and that includes the ability to analyze facial attributes, compare faces for similarity, or even train a facial recognition model to identify specific individuals. We've already discussed the computer vision service and its use in image analysis, and it also provides this OCR capability to read and extract text from images. Now, the service provides multiple programming interfaces, or APIs we call them, that software developers can use to extract both printed and handwritten text from images. And you can do that either by immediately synchronously reading a small amount of text in an image, or asynchronously parsing a large document and extracting all of the text from that. Now, the form recognizer service offers more than just detecting and extracting text. It enables you to use models that actually understand the form fields. So, for example, identifying specific types of data, such as addresses, phone numbers, dates, times, quantities, and so on, and understanding the relationship between the fields and the values in the form. Now, you can use the form recognizer to train your own custom form extraction models based on your own scanned forms. So if you've got a business with lots of different forms, you could scan them and train your own model. There is a pre-trained model for receipts that you can use. So if you have to do scanning of receipts or invoices, then you can use that pre-trained model to do that. So perhaps to build an expenses management system or something, you could use that pre-built receipt scanning model. Well, now it's your turn to try your hand at some computer vision, and what you're going to do in the lab is you're going to use some custom vision capabilities. You're going to use the custom vision service, and you're going to train an image classification model. So let's take a look at that. So the lab is based on this module in Microsoft Learn, Classify Images with the Custom Vision Service. And you're going to come in here, and you can skip past the introduction and the get started with image classification topics, and just go straight to the exercise on creating an image classification solution. Now, before you start that, you're going to need an Azure subscription, which you should have, but you're also going to need something called a Microsoft Visual Studio Code Space, which is an online coding environment that we can use to look at the lab contents and run some code. So I just need to go to this location here, and it will sign me in, and if I've not already signed in, I can just sign in using my subscription. And then I haven't already got a billing plan in my Azure subscription for Visual Studio Code Spaces, so it automatically is going to get me to create one of those. And then we're going to create this code space, and I'm going to give that code space a name, AI Fundamentals. I'm going to pull the contents from an existing Git repository. You don't really need to worry about the details of that, but that's where all the files that we're going to use in the lab are. So we're going to pull all of those into the code space. We'll set it up using the default settings here. So I just click Create, and off it goes to create that code space. and it will start to initialize the code space. This will take a few minutes just to go off and create the environment and pull down all the files that we need. So we'll just let that run and leave that until it's finished. And eventually the code space will open up. It looks like this. It's actually based on Visual Studio Code. And after a few minutes, all of the files from the lab repo will be brought down into this location here. And I can see the creation log has finished over here. And if I just monitor these files, I should eventually see at the bottom of the list of files this refresh now file appearing. And that's my cue to go and refresh the page. And we've configured this to automatically change the color settings so that we have this light background, and that's going to make it easier to read the code. Now, if you want to change the color settings to your own theme, you can use this little button down here and just change the color theme there. But we recommend you leave it on this light background here. And I'll just close these welcome pages. We don't need them anymore. And I've now got my lab environment ready to work on the labs. Now this particular lab is the image classification lab. So we'll go and open up that notebook. And that will load over here. It'll just take a few seconds to render the notebook. And eventually I get the information appearing. So there's some text for me to read there. But we'll just quickly go through what's going to happen in this lab. And what the first thing you're going to do is to go to the Azure portal and sign in using your Azure subscription. So we'll just click that link and we'll say we want to open that. And it signed me into my Azure portal because I was already signed in. And the next thing I want to do is I'm going to create a custom vision resource, and I'm going to use that for both training my model and for publishing the model so that I can predict from it. So let's go and create that custom vision resource. We'll just create a resource. Search for custom vision. And that's what I need, so we'll click create. Now I'm creating it for both training and prediction. I could create it for one or the other, but in this case I'm creating it for both. I need to choose the subscription where I'm going to create it and a resource group where I'm going to create it. So I'll create a new resource group, which I'll call Cognitive Services. I'll just put all of my cognitive services in that resource group. And I need to give it a unique name as well. So I'll just call it Graham Cust Viz. Viz. And that's not been taken by anybody. I get a little green tick, so I can use that name. Now I need to select the location and the pricing for my training service. So I'll just leave that in the US, and I'm going to use the F0, which is free. It's fairly restricted, but it's a free service just for me to try it out with. So we'll go with that. And I also need to choose the same thing for my prediction resources. So there's two resources being created here, one for training and one for prediction. Again, I'll do that in East US. And again, I'll use the free tier for that one. If the free tier is not available, you're only allowed one. So if you've already created something with that free tier, then you can use the S0 tier as well. So we'll go ahead and review that. That's everything I need. I'm ready to go and create that. And that will go and create those resources for me. And once the resources are created, I can go to the resource, in this case the training resource or the prediction resource. I've got both of those there. So if I actually go and take a look at the resource, this is the Graham Cust Viz resource. This is the one that I would use for training, and it has its own set of keys and endpoints that cognitive services all have. But if I actually go and look at the overview of that, this thing is in the Cognitive Services resource group that I told it to create. And if I go and take a look at that, there are actually two different resources in there. I'll just close this so we can see a bit more clearly. There's the Cust Viz, that's the one for training, but we've also got the Graham Cust Viz prediction, which is the one that I will use for predicting. So just be aware that it's created two separate resources, each with their own endpoints and keys. One that I use for training, one that I use for prediction when I publish my model. All right, so what's next? Let's go back to the lab. We've created that, and now I need to create a custom vision project. And to do this, I am going to have to download and extract some images. So I have a URL here for that, so I can just click that. I'll just save that here. And when it's downloaded, if I go and have a look at that in its folder, I can extract that archive. And the training images folder contains 3 folders, one that has images of apples, one with images of bananas, and one with images of oranges. So I'm obviously going to create a classification model that can tell the difference between apples, bananas, and oranges. Well, let's go back to our lab. We've now got the images that we need to work with, and we're going to use the Custom Vision portal to train our model. So we'll go and open that. And I'll just sign into that portal. And the first time I sign in, I'll need to agree to the conditions. And I currently don't have any projects. I'm ready to create my first project. So we'll go and create a new one. And we'll give it a name. This is going to be for an automated checkout at a grocery store. So we'll just call it grocery checkout. Grocery. We can give it a description. Image classification for groceries. And I can choose the resource that I want to use, and this is the resource for training. So I'm using my Graham CustViz resource that I created previously as my training resource for this. The project type is classification. We're not doing object detection, we're doing classification. It's multi-class classification. I have multiple classes. I have apples, oranges, and bananas, and there is a single tag per image. It's either an apple, an orange, or a banana. And there are some pre-built domains which will actually improve the performance by taking some existing trained models and building on top of them. So there are existing models that can identify food, and that's what we're dealing with here. So we'll choose that food existing domain, and we'll go ahead and create that project. So it creates the project, and the first thing obviously I need to do is to upload some images. So I will add some images. And I will go to that folder that I downloaded. And first of all, let's upload all of the Apple images. So I'll just Control A to select them all. And when I upload them, I want to give them a tag. So the tag I'm going to give them here is Apple. And we'll upload those 15 files and tag them as apples. Well, now I need to upload the rest of my images. So I've got a little plus button here to add images. So I will go and get my bananas. And again, I can add a tag for these ones. So these are banana images. And then lastly, I will upload my orange images. So we'll go to orange and add that tag. So now I've got all of my images uploaded in here, and I can see all of the tagged ones. If I had any untagged ones, I could view them, but of course there aren't any because I've just tagged them all. And I could filter them to just show me the apples or the bananas or the oranges. So I've got all of those in there ready to go and train a model. So to train the model, we have this green button up here to go and train the model. And I'm going to do a quick training just to get this built fairly quickly. So off it goes. And it's going to go and examine those images and use the features of the images, so the pixel values of those images, to train a model that can classify those different images. And it finishes fairly quickly, and I get back some performance metrics here, all of which are very high. I'm getting 100% precision and recall, so clearly it's a pretty good model based on what we've got. So I might want to go and test that model. And to do that, I have this option here to quickly test my trained model. So I can go and open up the test interface, and I could either upload a file or I could enter a URL. And if I go back to the lab instructions, there is actually a URL I can use. Here it is. So we'll just go and grab that. And we'll test our model. And it finds the image and it comes back with a prediction down here of an apple at 99%. 0% chance of it being an orange and 0% chance of it being a banana. So we're pretty confident that is an apple, and it is indeed an apple. So that looks like we have a pretty good model based on that very limited testing. So assuming we're happy with that model, we're now ready to publish that and use it from a client application. And to do that, there's a button here. It's the publish button, and we'll go and click publish. Now the model needs a name, and in this case, we've got this model name. The default is iteration 1. It gets named after each training iteration that we've done. But I'm actually going to just change that to groceries. And the prediction resource is where I want to deploy this. And remember, we created two resources. We created a training resource and a prediction resource. So I'll choose my prediction resource, and I will go and publish. And that says that is now published, which is good news. Now, to use this model, there's a couple of bits of information I'm going to need. So I'm just going to pop back to my lab file here. And I've got some code down here that I need to use. I need the project ID, I need the key for the prediction resource, and the endpoint for the prediction resource. So let's start with the project ID. And I'll go back to my custom vision environment. So I'm in the project. This is my grocery checkout project, I can see over there. And there is a little settings icon here. And that will give me the project ID. Here it is here under the project settings. So I'm going to grab that. And I'm going to go back to my code and paste that project ID into here. So I've got the right project ID. Now I need the key and the endpoint for my prediction resource. Now, somewhat confusingly, over here in my project, I can see the key and the endpoint for my training resource, and that's the wrong resource. I need the one that I deployed it to for prediction. So these are not the right settings for me to use from the client. What I actually need to do is go all the way out of this project and back to the project's gallery, and then look at the overall settings for my computer vision service. And here I've got both of my resources. Here's the training resource, here's the prediction resource. And in the prediction resource, I need the key and the endpoint for that. So it's a little confusing. You do need to back out and get that, but I'll take my prediction key and paste that in here. And then I'll get my prediction endpoint, paste that in here. And the model name I gave it was groceries, so we should be good to go there. So I'll just run this code cell here, and I'm now ready to predict using the model groceries in the project and then the big long project ID. So we're ready to go now. Now there's some code here. You don't have to worry too much about the details of the code. We're using the Python SDK. You could use the custom vision service from pretty much any programming language. We happen to be using Python in this case. But the important thing is we're reading out of a local folder. We have a folder in here, data, image classification, test fruit. So we have a bunch of images in there, and we're going to go and read those. We're going to use our endpoint and our key to connect to our service, and then we're going to display each of those images, and we will use our service to classify it. We'll get back the predicted tag name, so it'll be either apple, orange, or banana, and we'll display that. So that's all this code is doing. Don't worry too much about the details of it, but I'll just go and run the code. And it's going to call that service, and for each of the images in that folder, it's going to get a prediction. And when the predictions come back, here they are here, and I can see above each image is the predicted class. So I've got apple, apple, banana, orange, banana, orange, apple, banana, orange. And it seems to have predicted all of those correctly using that service. So in this model, we took a look at some computer vision concepts. We talked about what computer vision is and the types of things that we can do with it. And then we looked more specifically at computer vision in Azure. And we looked at the different cognitive services that are there that you can use to build AI solutions that interpret the world visually. Now, as always, there's more to learn, so you could look at this learning path on Microsoft Learn to explore computer vision. And here's what that learning path looks like. We have the Explore Computer Vision in Microsoft Azure. And that has a bunch of different modules in it. So there's the Analyze Images with the Computer Vision service, where you can look at some of those tasks where we extract descriptions and tags and moderation information for images. Then there's one on classifying images, which you've actually done in the lab. You've been through and used the image classification, but there are some additional topics in there that you might want to go and take a look at. Then there's another one on the custom vision service, this time building object detection solutions. So you go and learn how to build a model that detects objects and returns boundary box information about where those objects are in the images. There is a module on detecting and analyzing faces using the face service. Then one on reading text using the computer vision service. And then finally a module on analyzing receipts using the form recognizer service. So there's lots of interesting tasks in there that you can look at that are related to computer vision, and this learning path on Microsoft Learn will certainly help you explore those.